Hello students. Here today we will be discussing about surface area and volume. So we will be seeing what do we mean by surface area and volume. So let's begin into our topic. Okay. So the first, if any figure such as cuboid, if you recall what is cuboid is just to visualize, just see a box. Okay, so if you have seen a box, a wooden box or metal box, any box which is of like this. Okay, so this solid figure we say cuboid. Okay, cuboid which has three dimensions. First, length, width and height are known as three dimensional figures. And whereas if you recall the rectangle, in rectangle we have length and width, only two dimensions are there. Okay, so you know the difference between 2D and 3D. In 2D there are only two dimensional values, and in 3D there are three dimensional values. The additional value is height. We add height to get our 3D visualization. Okay, so let's move to next. Now the 3D figure, in 2D, what do we have? We have area as main element, and in 3D we have volume as our main element. Okay, and in 3D there is also surface areas. Okay, area covered by any three-dimensional figure. For example, if let's say you are in a room, so room is an example of a cuboid. Room is an example of a cuboid. Okay, so cuboid. Okay, so cuboid and room. Okay, and if you see that you can have four walls in room and one ceiling and one floor, so total six flat surfaces. You will see six flat surfaces. Okay, so room is an example of a cuboid. Okay, so in a cuboid there are six faces, as you can visualize by visualizing a room, and eight vertexes. What do we mean by vertex? Is the corners. Okay, so in a room there are eight corners. Let me draw for you. So a box will look like this, and we have eight corners: 1 2 3 4 and 5 6 7 8. These we called vertices. Okay, now there are 12 edges. Edges means these lines, or these are the line joining two vertexes. We call edges. So edge 1, the 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So 12 edges and 8 corners, or we say here vertices, and 6 faces. Faces means flat, the flat surfaces or flat rectangles. Okay, flat surfaces or rectangles. If you see, there are 6 rectangles. Now, the other point to remember is that the total surface area covered by a cuboid is what? So the total surface area, or the short form we will use, is TSA. So the surface area from which cuboid is formed. So we know we have 6 faces, rectangular faces or rectangular flat surfaces. So each of them having area, we can easily calculate, because the rectangle area is equals to length into breadth. Okay, so if you try to see, we know this height. So this height is h. Okay, as you are seeing in the image. So this is h, the red one is h, the green is L. So this is L, 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 and this orange one is blue. Okay, so this is blue. So if you are seeing, so I am taking the this rectangle enclosed by the 2 red line here, this and this, and 2 green lines here, this one and this one, and this area is equals to L times, because the green line length is L and red line length is H. Okay, H, so L times H. Okay, and similar area or the similar rectangle will be on the opposite side of the cuboid or the box, because if you see, these 2 sides is also red, and this, the back of the box or back of the cuboid is the same rectangular formation. So the area, we have 2 same rectangular pieces in cuboid out of 6. So we have the area equal to uh, 2 times. Okay, so 2LH. Okay, now what? Now if you see the side walls or the side rectangle which is in between these 4 lines, and this area will be same as this area, because it is also enclosed by these 2 same length of sides, which was of red and orange. Okay, so the now the area for the rectangular enclosed by the orange and the red line is equals to, because the red line is H and the orange line is B, and these are 2 boxes. So 2 boxes are there, so, or 2 pieces, 2 rectangles are there, 2 rectangles are there, so that means 2BH. And now if you see the top most rectangular piece enclosed by green and the orange one, okay, green and the orange, and this rectangular piece is the same as the rectangular piece formed in the bottom. So here if you see this one and this one. Okay, I hope you are seeing it clearly. Now area for that rectangular piece is, so piece is B, or the orange length is B and the green length is H. So it is BH, sorry, B, and green one is L, so BL, LB or BL, and we have 2 boxes, 2 such boxes, 2 such rectangles. So we have in total 2 times LB. Now we have two boxes for this piece, we have two boxes for this piece, and we have two boxes for this piece. In total, we have this area plus this area plus this area. So TSA will be 2LH plus 2LB plus 2BH, which is further equals to 2 taking 2 common, LB, BH and HL. I hope this is clear to you. What do we mean by surface area or the total surface area, and what is the formula to find out the cuboid total surface area? Okay, so so the total surface area is what we already derived. So 2 times of L times B plus B times H, H times L. Now to see the lateral surface area, or we mean by the area of the 4 walls. So the 4 walls, if you try to go back, so the 4 walls, if you see, okay, so let me draw for you again. So this is my cuboid. Okay, this is my cuboid and it has 4 walls. So one is this one, second is this one, third is this in front of me, the third wall is this third, and the fourth wall is opposite to the front wall, which is this. So I know this is L, this is B and this is H. Okay, so H is of my this red, okay, and L is of green color. So this is the L, the H and B. Okay, so B is of blue color. So B length is this. Okay. Now to find out the area for 4 walls is of the area, we are finding that this rectangular piece with B and H its height, so area is B times H, and because the same rectangular piece will be formed here also, so the area of the both of the first and the second wall is equal. So the first area of a first wall, area for first wall plus area of second wall is equals to BH plus BH, because both of the areas are equal, imply 2BH. Okay. In a similar way, we can find out the area for 3 and 4th, and we know area for a wall 3 is equals to the area for wall 4 is equals to same. So we know the area is L times H. Okay, and the total area will be 2 times LH, and the area for the 4 walls, is 2 times, so area for the 4 walls is 4 wall, the total area for 4 walls is equals to 2LH plus 2BH is equals to 2 taking common and L plus B and taking H common. So we have this. So okay, so this is my formula. So 2H or 2L plus B H. Okay, now the volume of cuboid is area of base times height. Okay, or we say LBH. And remember, the length of diagonal is equals to the L square plus B square plus H square and root of all. Okay, I hope you are having no difficulty to understand these formulas. Let's move to next. Okay, Now, for in the case of cube, and it is a special case for the cuboid because in cuboid we took length as L, breadth as B, and height as H. And in cube we have L is equals to length is equals to length, breadth is also equal in the breadth is also equals to length, and height is also equals to length. If all of the sides of a cuboid is equal to each other, then we call it as a cube. And it also has 6 faces, and each faces is look like a square because all of the sides are equal. In previous cuboid, the pieces were looking like a rectangle because one of the side is different to another. Here the all of the sides are equal, so the each face will look like a square. Okay, and the same formulas will hold here, but we substitute the values because all the sides are equal to each other. So let's see how our formula will look like. So in if you recall, in cuboid the formula for total surface area was BH, HL and BL, and by putting just B equal to H equal to L equal to X, if you are assuming a cuboid of side X, okay, then we have x square plus x square plus x square, which is equals to 3x square, and 2 is already there, then that means TSA or the total surface area is equals to 6x square. Now for the lateral surface area we had, if you recall, 2 L plus B times H. So that means we have now is 2x plus x into x, which is equals to 2x uh, 2 2x into x, which is equals to 4x square. So the formula is 4x square. Now for the formula for the volume, we had L into B into H, all are equal in cube, so x into x into x, which is equals to x cube, and the length of a diagonal is equals to in previous we had L square plus B square plus H square. Here x square plus x square plus x square root, and it is equals to 3x square root, and we can take out x because it is x multiply x. Whenever we have a pair of same number inside a root, we can take that number outside the root. So this, I hope you can easily recall these formulas without any issue. Now let's move to next. Now we are seeing a cylinder. So what do we mean by cylinder? So cylinder is just nothing, a shape looking like a pipe. So you saw a pipe. A pipe is just assume, or you can all saw a drum. So drum is an example of cylinder. So drum is an example of cylinder. Okay. So in a drum we have this type of 2 circles up and down, and the middle part is curved. Okay. I hope you are visualizing what I am saying. So now the curved surface area. So the curved surface area in the cylinder is the part this. What I am shading with the red. So this is my curved surface area. So if you open a cylinder or just cut a cylinder from the this middle line, then you will get a rectangular piece. Okay, so you will get a rectangular piece with the width h, because the cylinder height is h, and this, if you see this r is the radius of the circles be up and down, and if I cut and open the cylinder, what will be my this length? Length is the circumference of this circle. So the circumference for this circle is 2 pi r. So it is 2 pi r. So the curved surface area CSA is equals to 2 pi r h. Okay, let's move. So the curved surface area for the cylinder is 2 pi r h. Okay, let's move. Now the total surface area. So we already know the curved surface area. So the curved surface area is this the red shaded region, and the red shaded region, and in total surface area we want the area added is this. Now we add the area covered by this circular part. So we already know the area for this circular part is pi r square, and the pi r square is here. So we add all of these values. So 2 pi r h, pi r square, we will get this formula. Okay, so 2 pi r plus h plus r. I hope this is also clear to you. Now let's move to what is our volume of a cylinder. Now volume of a cylinder is just nothing, the area for the circle times the height. So area for the circle times height, because if you see, I'm just putting little circle over one over another till this height. Okay, so I will be getting my volume. So this is area of a circular okay, and times height, which is h. Now the volume is equals to pi r square h. Always remember its unit something cubic units. Okay, in area we used something like meter square or centimeter square, etc. In volume, whenever we find volume, we use a meter cube, a centimeter cube, etc. Okay, now let's move to next. Now the curved, now we will be talking about the hollow cylinder. Now in hollow cylinder, what do we mean by hollow? Hollow means the empty. Okay, so we know the cylinder is look like a drum. Okay, so drum is like this. Okay, now what do we mean by hollow cylinder? Hollow cylinder is like if you see, I have a cylinder, for example, like this. Okay, now I just carved a hole inside it, then my cylinder, now the new cylinder will look like this. Okay, like this. This is the hollow part which I carved through a wooden cylinder. So this is hollow. Hollow means empty or vacant. Okay, so if you see that I have two radius now, one is for bigger cylinder, that is R, with R, capital R radius, and one with the small cylinder. If you try to see the topmost view of the hollow cylinder, it will look like this, the blue cylinder, and this is the hollow part of the new cylinder which I just carved. Okay, so this is my small r, and this is my capital R. Okay, so the curved surface area is just nothing to the, it is similar to the because 2 pi r plus, now there is another. So we already know the cylinder curved surface area is 2 pi r h. Here there is another cylinder, so we will add the curved surface area for that cylinder also. So it is 2 pi r. So here r is small, so 2 pi r. So adding both the curved surface area, we will get the new hollow cylinder curved surface area. Now the total surface area of hollow cylinder. So in previous, the cylinder total curved surface area was 2 pi RH plus 2 pi R square. This is of because the two circle present up and at the bottom of the cylinder. So it will become 2 pi R H plus R. Okay. So now in hollow cylinder, we already know that we have two cylinders now. So for the old cylinder, we have 2 pi R H plus pi R square. Okay. And for the new, it is 2 pi R H plus, sorry, it will be minus pi R square. Why we are subtracting? Because this is the curved surface area for the cylinder, and okay, for the old cylinder or the cylinder with bigger R, and this is the curved surface area for the new cylinder or the cylinder with the radius, small radius R. Now if you try the, because we want to evaluate the total surface area and we already knew the curved surface area, the only thing we have to added is the upper part of the surface area, which looks like this. This is R, this is capital R. Okay, and we know this blue region is empty. There is no solid part here, no solid part here. Okay, and but this is all solid. Okay, this is all solid. So we need to find out this green area, and then we add to the curved surface area plus this green this green area to find out our total surface area. So the green area is the area of a bigger circle. Okay, so it is pi R square minus area of the smaller circle, which is pi R small r square. Okay, I hope this is clear. That's why we are using plus here and minus here. Now just add all of the terms, you will get this as our formula. Okay, now let's move to next. Now the volume of the hollow cylinder. So we already know the volume for the cylinder. It is equals to pi r pi radius square into h. Now here we have the hollow cylinder. So we just do nothing, just subtract the volume of the previous cylinder to the new cylinder. Okay, so this is our bigger cylinder minus this is our newer cylinder. I hope this is also clear. So the outer radius of the cylinder or the bigger cylinder, or this is for the height of the cylinder. Okay, so now height remains the same as you see. The only thing remains changed is the radius. Sorry, the only thing changed is the radius, because the for the outer cylinder or the bigger cylinder we are using the capital R, and the for the inner cylinder or the newer cylinder we are using the small r. So this will be our volume for the hollow cylinder. Now let's move to the cone. The curved surface area for the cone is pi rl. So pi is just a constant, and r is the radius of the circle below, and l is the slant height, and there is a relationship between h is the height of the cone. So h is the height of the cone. This is my center of the circle, and this is the uh, the apex point on the cone. Okay, the topmost point on the cone. Okay, topmost point of the cone. So the length between these two points is h, and there is a relationship between L, H and R, which is, because we know it is of 90 degrees, so using Pythagoras we have L square is equals to R square plus H square, or we can rewrite it as R square plus H square. I hope this is also clear. Now the total surface area of the cone is the curved surface area and the base area. Base area is a circular area which is pi r square, and the curved surface area we already know it is pi r l. Okay, now let's move to next, which is the volume of the cone. So volume of the cone is this, the 1 by 3 pi r square h. So pi r square h times h divided by 3. So whereas h is our height, r is the radius of the base, l is the slant height. Okay, so now let's move to sphere. In sphere, the sphere means a ball. If you try to visualize what do we mean by sphere, sphere is a ball. Okay, so ball, the total surface area for the ball is 4 pi r square, and the volume of the sphere is 4 upon 3 pi r cube. Don't confuse with this. Okay, so in total surface area we are using square, in volume we are using the cube. Okay, now let's move to the hemisphere. So sphere is the ball. Now hemisphere is the half ball. So we cut down our sphere into two equal parts. So we will be remaining with hemisphere. So the hemisphere curved surface area is the half of the curved surface area of sphere. So the curved surface area for the sphere was this. So we divide it into 2. So we will get 2 pi r square. We will do the same for this. Okay, so the curved surface area, sorry, the total surface area is the curved surface area plus other area. What do we mean by other area here? So in hemisphere, if you see, this is my curved surface area. So the curved surface area is this. So this is my curved surface area, and this will be my, and this area, the area below the formation of the circle, is my other area. So the area is pi r square. That's why it is pi r square. So adding this will give me 3 pi r square. I hope this is all clear. Now volume is, we already know the volume is 4 pi r cube, and then dividing it by 2 we will get the volume for the semi or the hemisphere. So which is equals to 2 by 3 4 upon 3 pi r cube divided by 2 is this, the 2 upon 3 pi r cube. So thank you for today.